All right, so next topic is Hadoop Introduction. So here we are going to talk about the concept of Hadoop. We don't have a lab for this, so basically this is mainly to understand the concept of Hadoop. So we're going to start with the big data analytics, and then we're going to talk about what is and why we want to use Hadoop for big data analytics. And we are going to compare Hadoop against other technologies, especially RDBMS, a relational database. And then we're going to talk about the Hadoop architecture, and I will talk about Hadoop ecosystem, meaning, besides MapReduce and HDFS, there are in fact a bunch of other technologies that make Hadoop useful. So we're going to actually talk about those technologies a bit. In fact, we're going to actually spend the rest of the code camp understanding and learning those ecosystem technologies, okay? And we'll talk about Hadoop usage examples. Big data analytics. So what is big data? Big data is a collection of data sets so large and complex that it becomes difficult to process this huge data set using traditional data processing technologies, especially RDBMS. So basically what we want to do is we want to capture this data set, we want to store, we want to search, we want to share, transfer, analyze, and visualize this big data, okay? Another characteristic of big data is unstructured, in terms of their schema. So compared to RDBMS, we are talking about structured data, but big data is typically unstructured data. And you can see this unstructured data is exploding. So if you see this trend, the structured data typically handled by relational database is actually, see the increase of the data size is actually a lot smaller than unstructured data. So the types of unstructured data we are talking about is, it could be text, it could be images, it could be audio and video. Okay, so moving forward, the size, the unstructured data is actually exploding compared to structured data. So these are big data examples. The Facebook has 400 terabytes of data, and they add 20 terabytes each data per day. And New York Stock Exchange generate 1 terabyte of trade data per day. Internet Archive stores 2 petabytes of data, and it grows at a rate of 20 terabytes per month. And Skybox Imaging, 1 terabyte per day. And Ancestry.com stores around 2.5 petabytes of data. So again, the size of the data is actually beyond what, beyond the level of what could be, beyond the threshold that could be actually handled by traditional technologies, again, especially from RDBMS standpoint. So big data evolution. So if you see, the technologies that have evolved during the past, let's say 20 or 30 years, we have ERP and then we have a CRM. Then the web is actually sort of taking over. So, and then big data is coming to the picture. So again, the type of big data we are talking about, user-generated contents, social interactions and feeds, and the spatial and GPS coordinate information, external demographics, business data feeds, and HD video and audio images and speech to text. There are lots of data that is actually coming into the picture of a computing platform. Okay. All right. So this is a useful picture. Now, challenges in handling big data. Okay, so if you're trying to handle this big data using traditional technologies, again using relational database, these are the challenges. Slow to process. So it might take 11 days to read 100 terabytes on a single computer. Okay, it's slow to move data. So moving this big data over the network is slow. And the scalability is also a big issue. So scaling up, in this case, a vertical scale, adding more memory and adding more powerful hardware has a limitation. And hard drive capacity is also limited. A single hard drive cannot accommodate the size of big data you're talking about. And unreliability, failure in computing devices are inevitable. So these are the issues that we need to think about when we are dealing with big data. So these are, again, the set of big data characteristics. We are talking about very large and distributed aggregations of loosely structured or unstructured data. And we're talking about petabytes or even exabytes of data. And flat schemas with a few complex relationship, meaning there is no real structured schema that define this data. And another characteristic is that the data are not really kind of interrelated. So this is the reason we say few complex relationship. Again, this is a difference from relational database. In relational database, you have tables that are related through join key and foreign keys and things like that. In big data situations, we don't actually expect these data to be interrelated. Okay. Often involving timestamped events. So if you have a lot of logs, that typically, those logs typically have a timestamps information, often made up of incomplete data, okay? And often including connections between data elements that must be probabilistically inferred. Again, this is somewhat related to the few complex relationship, meaning the relationship between data. If you want to actually extract some relationship, then you are going to use a different scheme other than like a foreign key and join key in the case of the relational database. Challenges in big data handling. One challenge is that moving data from storage cluster to computation cluster is not feasible. So we are talking about terabytes and petabytes of data. You do not want to move around this data to the computer for processing. Instead, you want to move your computing logic to the data. Okay, so that is what Hadoop is actually allowing you to do. You want to move the computing logic to data instead of actually moving data to computing logic. In a large cluster, failure is expected. Of course, the machines, we know the machines and networks break down. So we need to have a scheme where this failure of machines and networks is actually is actually taken into consideration, okay, to provide a reliable distributed system. And in fact, that's what Hadoop provides. It is expensive to build reliability in each application. So in order to actually have reliability, one option is you have this reliability scheme built into each application. And of course, that's not really efficient. We want the framework, in this case Hadoop, to provide this reliability as part of the platform. Okay, so we can actually talk about how Hadoop provides this reliability and distributed storage in detail moving forward. All right, the things to consider in big data. So when you actually see big data, you can actually see these 4 different aspects. Okay, so first, again, we talk about the volume. You're talking about very, very large size of the data. Another aspect is velocity. So the speed of this data is coming into your data set is actually pretty fast. Right? So that's velocity. Variety. The types of data is very is actually basically talking about unstructured and loosely structured data of all kinds of types. So we're talking about different types of data. And the value. So, basically the whole idea of using Hadoop is, from this huge amount of data, what is the basically business value that you want to extract from? And that's basically what Hadoop lets you do it. From the data set, you are going to actually find some meaningful business data. Examples of public data set. In fact, you can actually go out to the net, if you just Google public data set, you will actually find lots of places where these public data sets are available. Okay, so US government has a website where it does have maintained lots of the public data. Amazon has actually a website that actually maintains some data. Another example is the weather data and song data and movie data. There are lots of public data set you can actually take advantage of as a data source. All right, moving forward. So what is and why Hadoop? So you can think of Hadoop as a framework that allows for distributed processing of large data sets across clusters of commodity computers using very simple programming models. It sums up what Hadoop is all about. It's a framework, and the data are distributed, and we're talking about very large data set, and they are distributed across the clusters. And this cluster is made up of commodity computers. Okay, so we're not talking about very expensive computer. We're talking about commodity computers. And the way you can use Hadoop is very simple, very simple programming model. It is designed to scale up from a single node to thousands of nodes, each providing computation and storage. So in our code camp, in a development environment, we are actually using a single node, okay? But in production environment, you're talking about thousands of nodes. But from a developer standpoint, the way you are going to use Hadoop is exactly the same, whether you are using a single node or thousands of nodes. The distribution of your data and distribution of your computing logic, those are all handled by the Hadoop framework. In terms of Hadoop historical background, it started as a sub-project of Apache Notch. It's actually Notch is for indexing the web and expose it for searching, it is open source alternative to Google, and it started by Doug Cutting. He's now actually a chief technology officer in Cloudera. And in 2004, Google published what is called the Google file system and MapReduce framework papers. And so Doug Cutting and Notch team, they implemented this Google file system and MapReduce in Notch. And in 2006, Yahoo hires Doug Cutting to work on Hadoop. So that's where Hadoop is actually born. And in 2008, Hadoop became Apache top-level project. So why Hadoop? So what is the value of Hadoop as the handling the big data set handling framework? It is scalable. By simply adding new hardware, two new commodity machines to the cluster, you are basically providing scalability. Economical, because you're using commodity machines rather than millions of dollars of machine. It's efficient by running tasks where data is located. So you're basically moving your computing task to where data is located rather than the other way around. Okay? It's flexible because it handles schemaless and non-structured or loosely structured data. Okay? So any data can be handled by Hadoop. Fault tolerant or reliable because it provides self-discovering failed nodes and self-healing by distributed failed jobs, and data reliability by replication. So we're going to talk about this aspect in detail later on. Reliability by replication is that each data is in a form of a block, which is typically the size of 64 megabytes or 128 megabytes block, and this block is replicated on different machines. So that's where the data reliability is provided. In terms of failing nodes, the job, if a particular machine was handling a particular job, and if that machine has failed, then the job will be redistributed to another the node for the for processing. So fault tolerance is built into Hadoop framework. It's simple. It's by using simple programming model. And it's evolving because it has a very vibrant ecosystem. In fact, the Hadoop, when we talk about Hadoop, typically we're talking about MapReduce and HDFS. But on the top of it, there are lots of ecosystem technologies. And that's something we're going to talk about in the latter part of this presentation. So design principles of Hadoop. So store and process large amounts of data. So it is designed for handling large data sets. And it scales on performance, storage, and processing. So the scalability is built into it. And as we talked about, computing, in this case, code moves to data instead of data moves to code. Because again, we are talking about very large data set, and it's inefficient to move data around. Self-heals, recovery from failures in devices and networks are built in. Okay, so it's all handled by the Hadoop framework, so you don't have to actually deal with it yourself. Okay, again, it's designed to run on commodity hardware. Okay. Now, when to use and not to use Hadoop. So Hadoop is good for indexing data and log analysis and image manipulation, sorting large-scale data, and data mining. These are, the examples where Hadoop is actually useful. Hadoop is not for everything, however. So if you need the real-time processing, then Hadoop is not for that. Hadoop is a batch-oriented scheme. It's not real-time processing. And it's not for random access. Hadoop is not relational database. Okay? So it's not for random access. Okay? It's not for processing intensive tasks with little data. So this is actually, Hadoop is designed for large data set. Okay, and so if you have a task that is computing intensive with a little data, then Hadoop is not good for that. Okay, now some of these limitations, for example, like real-time processing and random access, those are in fact being addressed by Hadoop ecosystem technologies, however. Okay, so we can actually talk about those things in a few minutes. All right, comparison to other technologies. So let's compare Hadoop against relational database. So relational database typically dealing with a small data, of course, compared to Hadoop. Okay, so Hadoop, we are talking about the scale of terabytes and petabytes. Okay, relational database typically dealing with a strictly structured data, while Hadoop is loosely structured or unstructured data. RDBMS, relational database is, is a schema on write, meaning when you are writing data into relational database, that data has to meet the schema of the table, right? Okay. Hadoop, you can just save the data into the storage, and when you read the data, then you can actually impose some structure. So in this case, we call it schema on read. Okay. Relational database is again relational, meaning the tables are related through foreign keys and join table and things like that. Hadoop by nature is non-relational, meaning the data sets are not really related. Okay, you can certainly provide some relationship when you read the data. Okay, but by nature, data set itself, doesn't have any relationship to other data set. Relational database is typically transaction-oriented. Hadoop is mainly for analytics-oriented. It's not for transactional processing. It is for analytics. Okay. Relational database provides what is called the ACID properties: atomicity, consistency, and integrity and durability. But Hadoop is not ACID properties. Really, it doesn't actually provide ACID properties by nature. Relational database is typically for real-time query, while Hadoop is designed for batch-oriented operations. Okay, again, typically for analytics-oriented operations. Relational database lets you do frequent read and, of course, write and update. Okay. However, Hadoop doesn't allow you the update and delete. Okay, so it's typically initial write. You write a large set of data into the storage, and then it doesn't allow any update or delete of the row. Okay. RDBMS, relational database, is typically centralized. Of course, you have actually few machines that are they're connected, but it is still centralized. Hadoop is designed to be distributed. Okay. Relational database provides only vertical scalability, meaning you have to actually add more memory space, you have to actually buy a bigger machine and things like that. Hadoop is designed to be horizontal scalability in mind. So in order to actually have a scalability, all you have to do is just add new machines. So it is horizontal reliability. Now, if you actually compare Hadoop against the data warehouse, basically I'm going to just explain the big data analytics environment a bit. So data from many sources inside and outside of the organization, including traditional data warehouse. Data often physically distributed and need to iterate solutions to test and improve models. And large memory analytics also part of the iteration, and every iteration usually requires complete reload of the information. Okay. So I think the comparison of Hadoop and data warehouse is a little less kind of obvious compared to the Hadoop versus relational database. So if you actually understand this slide, I think that's actually good enough. Okay. So in fact, I'm actually thinking about taking this slide out a bit. All right, so let's move forward with the Hadoop architecture. So Hadoop is made of two core technologies, and one is called the MapReduce, and the other one is called the HDFS. So MapReduce is for processing, so computing logic, and HDFS is for storage. Okay, so these are two core technologies that make up Hadoop. So in fact, if you download Hadoop package from Apache, it comes with these two core technologies, MapReduce and HDFS. So MapReduce is again for processing. You can think of it as a framework for performing high-performance distributed data processing using divide and aggregate programming paradigm. So we can actually talk about this divide and aggregate programming paradigm later on in MapReduce presentation in detail. Okay. HDFS is reliable distributed file system that provides high throughput access to data. Okay, so these are two core technologies that make up Hadoop. Okay. Hadoop has a master-slave architecture for both MapReduce and HDFS. So in MapReduce, it has what is called the job tracker as a master, and then it has a multiple task trackers as slave nodes. Okay. Again, in our code camp, we actually use a single node, pseudo distributed operational mode. So we're going to actually have one single job tracker and one single task tracker node. But in production environment, you typically see a lot more task tracker node and one single job tracker node as a master. HDFS has the same master and slave architecture, in which it has a name node as a master, and then it has a multiple data nodes as slave nodes. Okay. So this is how the Hadoop is structured. So basically Hadoop is made of MapReduce and HDFS. Okay. So here we have so this is the job track on the left side. And we have one single job tracker node as a master, and then we have multiple task tracker nodes as slave nodes. Okay. And then in terms of HDFS, we have a master node called the name node, and we also have what is called the secondary name node. It's not for high availability; it's actually providing some extra features. So you can think of a name node and secondary name node as a masters, and then we have a multiple data nodes as a slave nodes. Okay, so we're going to talk about the role of name node and secondary name node and the data node in detail later on in HDFS presentation. I want you to focus on the fact that Hadoop is made of MapReduce and HDFS, and each of these MapReduce and HDFS is actually based on master and slave architecture like this. Okay. Again, MapReduce is for distributed processing, and HDFS is for distributed data storage. Okay. So typically, client will send a job request to task job tracker, and job tracker will actually figures out how the job could be actually divided, and it will send a task to each of these task tracker. Okay. All right. Hadoop ecosystem. So this picture actually shows Hadoop ecosystem, the things that we are going to cover. So on the bottom, Hadoop is made of HDFS as a distributed file system. And then we have a MapReduce that is for distributed processing. And then we have what is called the HBase. Okay, so HBase lets you in fact have some kind of structure. Okay, so it's actually another important ecosystem technologies. And then we have the data access technologies, Pick and Hive. And so Pick and Hive, Hive actually lets you do access the Hadoop using SQL like language. Okay, so this is for people who are familiar with the SQL, and you can use that SQL knowledge to use Hadoop. And Pig is actually the data flow language that is a lot easier to deal with than MapReduce API. Okay, Avro is actually RPC, remote procedure call technologies, and Scoop is actually for the importing and exporting data from existing relational database to Hadoop and vice versa. Okay. And the Uzi is actually workflow technologies. Typically, you have the jobs in flow. For example, if I want to actually copy some files from local file system to the HDFS, and then I want to actually perform some MapReduce job, and then after that, I want to send the email, and then I want to actually copy the result into Hive table and things like that. Okay, so Uzi is actually workflow technology. JUkeeper is actually a technology that is used to synchronize the distributed database distributed system. Okay. And Mahao is actually a machine learning technologies, and Solar is for the index and search technologies, and it's based on Lucene. Okay. So what we are going to cover in this code camp is actually Cloudera Hadoop distribution. So when you download the Cloudera Hadoop distribution, either in the form of Quick Start VM or the CDH package, these are the technologies that is pre-configured and pre-installed and pre-configured. Okay, so we are going to cover HBase, we are going to cover Pig and Hive, and we are going to cover Flume and Scoop, and we're going to cover Oozie, again, workflow technology. Oozie actually provides workflow as well as it provides a scheduling technology. For example, I want to run a certain job every 5 minutes and things like that. Metadata, that's actually Hive, and then UI framework Hue, and Hue SDK, we are not going to actually build the Hue, pieces ourselves. So we are going to actually cover Hue, Oozie, and Hive, Flume and Scoop, and Pig and Hive, and HBase, and Zookeeper is not, is actually underlying technologies. We are not going to actually cover that, but we'll actually talk about, how it is used with Hive. Okay, so this is the Hadoop distribution technologies, ecosystem technologies we are going to cover. So when you download and install Quickstart VM, and when you open the browser, this is what you are going to see. So when you click the Cloud Manager, these are the ecosystem technologies that are already started for you. So everything is pre-configured, and so all you have to do is just install the Quickstart VM. So this is, in fact, as I said before, easiest way to get exposed to all these ecosystem technologies without going through the pain of individual installation and configuration. This is the Hadoop ecosystem development. Okay, so in fact, this Hadoop ecosystem is evolving and very, very vibrant. Okay, and it has only information about 2011, but obviously, Hadoop is actually very, very popular these days, even in small organizations, and this ecosystem evolution is actually accelerating. Hadoop usage examples. So if you actually go to this website, basically each companies can actually, if you click this guy, this link, you can find out how each company is in fact using Hadoop. Okay, so if I go to, for example, F, and you can see Facebook here. So this is a post from Facebook. We use Hadoop to store copies of internal log and dimension data sources and use it as a source for reporting, analytics, and machine learning. And currently we have two major clusters, 1100 machine cluster with 8800 cores and 12 terabytes of raw storage, and 300 machine cluster of 2400 cores and 3 petabytes of raw storage. Each commodity node has 8 cores and 12 terabytes of storage. And we are heavy users of both streaming as well as Java APIs. We have built-in high-level data warehousing framework using these features called Hive. And we also develop huge implementation over HDFS. Okay, so that is from Facebook. Let's take a look at the eBay. 532 nodes cluster and heavy usage of Java MapReduce and Apache Pig and Apache Hive and Apache HBase, and using it for search optimization and research. Let's take a look at Yahoo, how they use it. More than 100,000 CPUs in more than 40,000 computers running Hadoop. Our biggest cluster is 4,500 nodes. Our blog, so basically, pretty much every company out there, especially internet companies, are taking advantage of Hadoop for various purposes. Okay. All right, so that is the repeat of what I just said. Twitter, of course, another big company taking advantage of Hadoop. So Twitter is using, so sometimes you get the recommendation from Twitter, the people, the people you might want to get connected. Okay, so Twitter is actually using Hadoop to find out, who are in fact the people that you might be interested. So yeah, basically we use Hadoop to store and process tweets, log files, and many other types of data generated across Twitter. We store all data in compressed LTO files. They use Scala and Java to do MapReduce, and they also use Apache Pig for both scheduled and ad hoc jobs, and we employ commuters. Yeah, so many of these companies, in fact, have commuters to Hadoop ecosystem technologies. We talk about Yahoo. All right, so that is the end of the presentation. All right, so let me just make sure that I have recorded this guy.